Hi Math 2 students. Today we are going to go over central and inscribed angles. So a couple of things I want to go over with you before we get started is just kind of some reminders and some vocab. So first off, I want you to remember that an entire circle is equal to 360 degrees. Now this 360 can come by adding up the angle measures of the arcs, which we're going to talk about what arcs are, and that can also come by adding up the measures of all of the angles that make up the center. All right, so basically if you add all of the arcs together or all of the angle measures together, you should end up with 360. So let's talk about what an arc is. All right, so if we got a circle, and we worked on arc length, right? So arc length is kind of just like a portion of the circumference, right? So that's what an arc is. I know we already covered that. But just as a reminder, and then half a circle is 180 degrees. So if you have this, you know that this portion is equal to 180. In addition, this portion is equal to 180. All right. And then an important piece of information is that a diameter cuts a circle in half. Okay. Only a diameter does. If it doesn't go through the center, it doesn't cut it in half. Okay, so like this is bad. It doesn't cut the circle in half. In order for it to cut it in half, it needs to go from one end through the center to the other end. And then we have some terminology. We have a central angle, all right? So a central angle happens where when the vertex of the angle is on the center of the circle. All right, so this right here is a central angle. Then we have something called an inscribed angle. All right, and in an inscribed angle, the vertex is on the circle. All right, so these are important pieces of information. So there's a relationship between central angles in the arc and inscribed angles and the arc. All right, so as we talked about, a central angle has its center, or I should say its vertex at the center of the circle, and this is called the intercepted arc. That's the arc that that angle makes. All right, with a central angle, the measure of this guy is equal to the measure of that guy. So for example, if this is well, actually, we'll give a more reasonable measure. Let's say this is 30 degrees. That means that arc CD is 30 degrees. All right. Now, with inscribed angles, the angle is half of the arc measure. So, for example, if CD is 30, my inscribed angle is going to be 15. So you could think of it either as the arc is twice the angle, or the angle is half the arc. All right. Cool. So let's go ahead and try some problems. Let's apply this central angle idea. So if we look at this first one, they want to know the measure of this arc. Well, we just talked about how the angle is equal to the measure of the arc when it's a central angle. And you can tell it's a central angle because the vertex is on the center. So our question mark is going to be equal to 76 degrees. All right, so try this one. What do you think your question mark is going to be equal to here? So your question mark should be equal to your arc measure here, should be equal to 114 degrees. All right. These are all pretty simple. All right, cool. So now let's try and do some of these problems. So if we look here, this guy is a diameter, right? And we talked about how the diameter cuts the circle in half. So if this if this angle measure is equal to negative 35x plus 5, we know that half a circle is equal to 180. So we could say negative 35x plus 5 is equal to 180. And you would just solve from there. So you're going to do minus 5, you get negative 35x equals 175. Divide by negative 35, you get 175. Oops. Sorry. My calculator wasn't ready. Oh, 175 divided by negative 35 gives me negative 5 as my x value. We didn't even need this 95 here, and you're going to find that sometimes in these problems, they do give you values that you don't need. All right, let's try this one. So again, we talked about how the angle measure is equal to the arc measure when it's the central angle. So all we need to do is say 12x plus 15 is equal to 135. You solve from there. I get 135 minus 15, which is 120. I'm going to divide by 12, and I get 10. All right. So again, central angles are equal to the measure of their intercepted arc. Again, diameters cut the circle in half, so the measure of that angle or the measure of that arc is equal to 180. Now let's take a look at 13. We don't have any arc measurements, we don't have any diameters, but they did give us information on this entire circle. All right, and we know that the entire circle needs to add up to equal 360. So we can go ahead and say 12x plus 15 plus 7x plus 15 plus 140. That looks bad. Plus 140 equals 360. So go ahead and solve that. Combine like terms and solve for x. So when you do that, let's see, we've got 7 and 12, which is going to give us 19x. We've got 15, 15, and 140, which is going to give us 170, which gives us 360. Minus 170 gives us 19x is equal to 190. You get that x equals 10. Very nice. All right. We are making progress, my friends. So now let's go ahead and try, so these were all central angle problems. Let's go ahead and try some inscribed angle problems. So again, an inscribed angle occurs when you have the vertex of the angle on the circle. All right, so instead of the angle being right here at the center, it's on the circle. And in our notes, we learned that the measure of the angle is 1/2 the arc. So I know that the measure of this angle is going to be half of my arc measure that it intercepts here. So it's just 102 divided by 2, and we get that our question mark is going to be equal to 51. All right, so try this one. Again, the measure of the angle is half that of the arc. So we would just do 150 divided by 2, and our question mark should be equal to 75. All right. And again, we can try another one here. Now, as you can see, they might throw a bunch of extra lines in here, but it's going to be kind of up to you to realize, like, hey, I don't need any of these extra lines. They're useless to me. This is my angle of interest, and this is the intercepted arc. So my angle of interest is going to be 50. All right. And you know what? I wish I had put one in here where they gave you the arc and you had to find the angle. So you know what? We'll improvise here, my friends. Let's say I gave you something like this, and they told you that the angle measure was 32, okay? And I want to know the measure of arc AB. Well, the measure of the arc is going to be twice that of the angle. So this one would be 64 degrees for the measure of arc AB. Sorry, I didn't throw one of those on the notes. All right. So let's go ahead and try another one. So now they actually want us to solve for x here. So again, we know that the measure of this angle is half that of the arc. So there's kind of two different ways we could do this. I'm going to show you both ways, because sometimes one may work, sometimes the other may work better. we know that the measure of this angle is half that of the arc, so we could divide that by 2 and say, well, this angle measure is going to be 60, right? And we could set this equal to 60. Or we could say, well, 2 of these angle measures equals 1 of these arcs. So we could do 2 times 4x plus 16 equals 120, right? Because 2 of these equals 1 of these. So we should get the same answer when we solve both of these. So let's try it out. So 60 minus 16 is going to give us 44. I get x is 11. And then we get 8x plus 32. 120 minus 32 gives me 88. I get x is 11. So both those methods work. All right. So now let's try another one. Now for this one, they gave me the arc measures of the entire circle. Question, what is the measure of the entire circle? What should I add all of these up to equal? So the measure of an entire circle is 360 degrees. So we're going to say 149x plus 1 plus 130x plus 80x equals 180. We can combine like terms. We got 149 and 130. It's going to give me 279. Oh, just kidding. Hold on. I got to combine these, this, and this. I forgot about my 80x. So we do 149 plus 130 plus 80. And we get 359. And then we've got 1 equals 180. Oh, look what I did wrong. It should have been 360. Uh-oh. Hopefully someone caught that. All right, and then we're going to do minus 1. We get 359x equals 359. We should get that x is equal to 1. All right, let's do one more. You guys are doing good. So let's go ahead and try number 27. So again, we know this is an inscribed angle because this vertex is on the circle. And we know that 2 of the angles has to equal 1 of the arcs. So we're going to say 2 times 55x equals 110. You get, when you distribute this, you get 110x equals 110. We get another x's equal to 1. Nice job.